Okay, let's begin. This talk is entitled Hacking Without Reinventing the Wheel. I will be talking for the first few minutes, so bear with me. After that, Justin Clark will talk about Nmap and Hydra, and I will tell you more about what Justin will talk about. Basically, this talk came about because of our frustration with people using a lot of the out-of-the-box open source A&P tools, attack and penetration tools, from an out-of-the-box perspective, which is totally fine. But tools, for example, such as Nessus that we will be talking about, give you more than the simple out-of-the-box functionality, where you So tools such as Nmap, Hydra, Etacap, which is a great sniffer, these are all open source, and if you just want to download them and use them, given what they are when you get them, that's perfectly fine. But these tools also provide you a great framework of writing your own APIs and extending their functionality. And our frustration is with the fact that this great framework that these tools provide are ignored, are not known. Metasploit, for example, is a tool that HT probably talked about a few minutes ago. It provides an excellent framework for writing exploits. The thing that's right with Metasploit is if you go to the website and you look at the documentation, it presents itself as a framework. It's more than just a tool. It's more than just the exploits you get with the tool. Tools such as Nessus, Etacap also provide you with the framework, but unfortunately, the maintainers, I think, don't do a good job in presenting it as a framework. So the objectives of this talk is to first, let's discuss why we want to extend these tools, right? And if you want to extend the functionality of an attack and penetration tool, and if it's a closed source tool, it's going to be pretty hard, right? And what's happening these days in companies that can hire their own attack and penetration internal teams is, they hire a few consultants who come in, and by the time they're done, they hand you a report that says, you have this application that has this flaw, and thank you for your time, and they leave, right? So the internal attack and penetration team now has to have, what they end up doing is writing, a Perl script or a Python script to audit for those flaws that they know about. And one guy can write it in Perl and he gets hit by a bus. Tomorrow, somebody else wants to write it in Python. And so there's no real structure for doing this. And companies these days won't realize that because, they have a lot of cool people working for them in the A&P team. What they end up doing is reinventing the wheel, where people in internal teams in a lot of firms are rewriting scanning engines from scratch, where, for example, the Nessus engine is available, it's free, and in a lot of these cases, it does the job really well. But there's no awareness that, to write a plugin in Nessus, in the NASA language is so easy. So the objective of this talk is to go over the NASA language. I will show you how to write a plugin from scratch. We'll show you how to write an Etacap plugin. Etacap is a really cool open source sniffer. It's really powerful. We will see how to write a simple plugin. My aim is not to, in 1 hour, to show you how to write a groundbreaking plugin. Basically, I'm trying to fill the gap where there is no information out there on how to write these plugins. And so I will walk you through how to write simple plugins for Nessus Etacap. Justin will talk about how to modify Hydra. Hydra is an active password brute forcer. Justin has submitted a patch to Hydra, the Hydra team, which does, so to make Hydra now do SMTP auth brute forcing. I think version 4.2, which should be out soon, will have that patch in it. And so Justin will go through his code and how he modified Hydra and how perhaps you can modify Hydra to brute force your custom applications or protocols. And then Justin will show you how to extend Nmap to modified server signatures functionality. For example, if you have a web server running on port 23, which is reserved for Telnet, Nmap can detect that. But if you have a weird protocol that you internally use in your company, you can still change Nmap to detect that protocol, no matter what port it is running on. every company right now, either it's a small-sized company or a medium-sized company or a really large company these days, has n number of applications that are customized. Now, what does that mean? That means that these custom applications and programs will have custom flaws. So if you put down $500,000 for some of these closed source commercial network scanners, well, and if you use a custom application that you know, for example, there's a SQL injection flaw and you want to scan for that flaw on, for example, rogue hosts that may be on your network, it's going to be really difficult for you to convince the closed source scanner vendor to write a plugin or an update just for you. So before you patch your homegrown applications, you need to detect the problems with them first. And closed source tools for vanilla A&P scanning needs, they do a great job. But, when I buy a closed source tool and if I'm an A&P specialist, if I can figure out how it's working, then that's a problem. Because most of the attack and penetration tools, more than 10% of the time, or actually a lot more than 10% of the time, you get a lot of false positives from it. So if you don't have a knowledge on what is going on, then you're going to take those false positives and assume them to be true. So closed source tools, for example, will not allow you to look at, what they're actually doing. And I don't want to quote names, but I have seen some really rudimentary port scanning tools that are closed source, where vendors claim that they have specialized UDP scanning techniques, and if you really sniff for what they're doing, it's nothing specialized. So people can get away with that. That bothers me. It's really difficult to tweak these closed source tools to modify them to do what you want. And if you've ever done an A&P engagement audit before, you have to tweak tools to make them do what you want. Out of the box, most cases, things will not work. If you have custom flaws or protocols, well, good luck using out-of-the-box tools. And suppose you use a web application, CGI-based web application or PHP-based web application that you downloaded from some site somewhere, somebody gave it to you away for free, and you recently see a bug track posting for it, which is a flaw that you want to fix, but you also want to scan for. Now, if that application that you're using is not popular, then if you have a closed source scanning tool, if you call up the vendor and say, I want you to write an update or a plugin to scan for this flaw, that's not going to be on the top 10 priority list. So what do you do then, right? And these scanning tools, closed source scanning tools, are really costly. I've seen people actually buy them and spend so much money, and at the end of the day, they realize they can't really do much with it except then the functionality that it comes with out of the box. But at the same time, I'm not here to say that all closed source tools are bad. The model of companies that actually make these closed source tools are not to allow you to let you to extend their tools. Some of these tools are really great, but they are in a completely different model. So if you are in a company and you want to write your custom scanning software, don't waste your time with closed source tools. I don't know of any right now that are worth buying unless you just want to use it from an out-of-the-box perspective. Closed source tools also have some advantages that are probably out of scope for this talk. For example, you get an 800 number you can call whenever you have a problem. Good luck getting through, but you do get a support alias email address that pipes to DevNow. So then, open source tools, I know I'm kind of beating around the bush, but if you're performing an A&P audit, and if you don't use open source tools, if somebody asks, if you get, for example, if you do a fin scan on a Windows box, right, it behaves differently depending on what port scanner you're using, because Microsoft does not follow the RFCs pretty well. So if you don't know what you're doing, and if you just can't look at what the tool is doing, you will get bad results. And of course, with open source tools, if somebody's already done something that you want to do, just copy paste the code if it works for you. Of course, as long as you follow the license agreement. So what we will do next is look at the Nessus architecture. We will look at what the NASL language looks like. NASL stands for Nessus Attack Scripting Language. And we will quickly see how to write a very simple plugin, and then we will see how it looks like when you actually run the Nessus engine and the output from our brand new plugin. Then we'll go through AutoCap. AutoCap is an awesome sniffer. It's one of the really good sniffers that is free and lets you do app spoofing and it lets you sniff on switches. So we will write a simple plugin for AutoCap. What our plugin will basically do is that it watches for SYN packets on the network and alerts the user, the AutoCap user, that I saw a SYN packet fly by, therefore somebody is trying to establish a new connection on your network. Hydra, Justin will go over his patch for SMTP auth. Nmap, Justin will show you how to extend Nmap to scan for your custom protocols running on weird ports. So if you don't know what Nessus is a free open source GPL scanner. The good thing about Nessus is that it's in a client-server based architecture. Therefore, if you install Nessus, you can have the Nessus server sitting on one box, and you as a Nessus user will connect to it using the Nessus client. And that's a great architecture because it makes life much easier. For example, you could be out of your, you could be somewhere else and you could VPN into your office network and launch scans remotely. And of course, Nessus comes with NASL. NASL is, does not aim to be a powerful language. It's designed to do one thing, that is to let you write Nessus plugins, and it does it really well. But we'll look at that as we go along. I just threw the slide there so in case if anybody sees this after my talk, here's how to install Nessus. Okay. Once you connect to the Nessus server using the Nessus client, you will see a preferences tab, or plugins tab, sorry, where you will see all the plugins. Now when I say plugins, I also will mean, and when I say plugins and NASL scripts, I mean they're the same things. Nessus plugins are basically NASL scripts. So that is scripts written in the NASL language. So you will see a list of all the plugins categorized by family. For example, backdoor, CGI abuses, denial of service. So when you're using the client, and for example, if you're scanning a production host and you don't want to run denial of service checks on that, you can simply uncheck that. One other option that I want to mention is the safe checks option. The reason, if you look at the client, there's so many things you can configure, but the reason I also point out safe checks is in the NASL API, you actually have a function call which lets you check if somebody has enabled safe checks or not. So when you're writing a plugin, for example, if you want to test for a POP3 buffer overflow problem, right? The first thing you do is get the banner string from the POP3 server, and if the banner string includes the version information, well, you can kind of say, well, this version I know is acceptable to a buffer overflow. But if somebody has turned on safe checks, you can check it in your plugin, and then you will stop right there. If someone has turned off safe checks, you can go ahead and actually perform the buffer overflow check, which might crash the server. So depending on what you want to do. So once you actually start a scan and go through it, this is what a Nessus report looks like. On the top left, you'll see the subnets. If you have more than one host on a particular subnet, if you have more than one subnet, those will be listed there. And then on the bottom left, you will see the host section where it will show you all the live hosts it found. And of course, the ports that were opened and the warnings, right? What kind of flaws were found. And these can be categorized in 3 different categories: security warning, security note, and a security hold. Security note is basically just an informational item. If you look at the POP server detect plugin, all it does is it detects if the remote host that is being scanned is running a POP server. And so that is classified as a security note. It's just basically a notice giving you information. Security warning is a mild flaw. So if you look at the FTP anonymous plugin, what that plugin does is that it checks to see if the remote host is running an FTP server and if it has the anonymous account enabled. I would agree that that is a mild flaw, but Who makes this call is if you're writing the plugin, and since Nessus is an open source software, the person who actually writes the plugin probably gets to make the call if it's a security warning or note or a security hole. Security hole, severe flaw, example of it is the test-CGI plugin. What that does is it exploits the CGI call test, and which allows you to view local files on the host that is running the web server. And so I would probably agree that it is a severe flaw. As we write our sample plugin in the future slides, we will use a sample flaw, and we'll detect it, and we'll categorize it as security hole. You will see later. Before you start writing your own NASL scripts, a lifesaver is the NASL interpreter. Without the NASL interpreter, what you would really have to do is write a NASL script, write a Nessus plugin, put it in the right directory, connect to the Nessus server with the client, start your scan, and look at the output to see if you're doing things right. Now that can take a lot of time. So the NASL interpreter basically takes in the NASL script as an argument and runs it on the host that the interpreter is installed in. And also, if you ever want to check out sample or already written plugins in Nessus, this is the directory you'll probably find it in, and grep and more are your friends. Just look through these, and NASL, as you see, is a pretty simple language. So if you want to write a plugin that detects that does a denial of service attack, there are probably other people who have written similar ones. You can just look at them and change it to tweak your needs. This is the usage for the NASL interpreter. The option that we care about at this point is the --T option, which lets you provide a target IP address to run the plugin against. Now, when you actually write a Nessus plugin, and if you open a TCP connection to a remote host, the IP address of the host that you're connecting to is supplied by the Nessus engine. So when you write code, you never need to specify the IP address that you're scanning against, because that's already done for you. The Nessus engine calls your plugin for every applicable port that is found open on the host that is currently scanning. But if you run that same plugin from the command line, you have to tell it which IP address you want it to scan. So here's an example of using the NASL interpreter to run the finger plugin directly from the command line. You use the -T option and the IP address. The finger plugin is basically a simple plugin that tries to finger the root user. Finger is a Unix service that spits out information about currently or not currently logged on users. In this case, it executed successfully and said, I could finger the root user. It's not a good idea. So this is a good example of how you can test your plugins. Here's a customary hello world in NASL. Just call the display function with the hello world string and run it using the NASL interpreter, and you should see hello world. NASL as a language basically has two data types, integers and strings. Integers are numbers and strings are a collection of characters. I don't mean to offend developers in here, but I'm just going to quickly go through these just to give an idea of what NASL supports. I know most of the developers know what arrays are. Here's an example how you would define an array in NASL. You would call the makeList function, which returns you an array. In this case, the myArray index of 0 will have the value 1, and the index of 1 will have the string 2. Hashes are better than arrays. I think Perl also supports hashes. Hashes are basically arrays, but you index them using a key value. In this case, my ports with the, instead of the index, you give it the string telnet, and it will map to 23. HTTP will map to 80. So depending on what you want to do, hashes might be more convenient for you. Loops. Functions. The good thing about Nessus functions is that Nessus or NASL does not care about the order of the parameters. This given function called isEven will return 0 if port is odd, or 1 if it's even. But notice that when I call it and isEven, I have to provide the parameter name : the value. So if I had more than one parameter in here, I just need to include the parameter name, and the order of the parameters when you call functions does not matter. Now, plugins always need to interact with each other or in some fashion or the other, otherwise you'll be scanning for more than one thing twice, and your scans will take forever. For example, if you have an FTP anonymous plugin, if I write an FTP anonymous plugin, basically what it does, it tries to log on to the remote host with the anonymous account, and if you write another plugin that performs a brute force of commonly used FTP accounts, and in your plugin you also want to check if the anonymous account is enabled, well, if I've already performed that check, I can just put that information in the knowledge base and you could pick it up. And if that value is already set, then you don't need to perform the same check again. So it makes life much easier and makes Nessus more efficient. The API for that is, you call the set KB item function call. You give it a name and a value. So in this case, you say name SSL enable value true. And if another plugin wanted to get that item, use the get KB item, provided the name, and the value will be set to true. Get multiple items, you will use a get KB list function call. That behaves a bit weirdly, and every time I talk to someone about that, every developer tells me that's a really bad idea, but when you look at how plugins use it, it's actually a pretty good idea. Get KB list, if you, for example, say get KB list and say port/TCP/star, if somebody has set an item on the knowledge base, port/TCP/22, and one more item called port/TCP/23, what will happen is TCP, when get KB list executes, for every item that is returned, in this case 2 items, 22 and 23, the Nessus plugin will spawn a child process. So the current process will get the value 22, the child process will get 23. Sounds weird, but what happens is as you go through the plugin and do whatever you want to with those values, now you have plugins going in parallel and you don't have to do multi-threading, right? So it's written with a specific purpose in mind, and it's kind of, if I like it, some people think it's a really bad idea. So for an example plugin, what we will do is we'll assume that a web application serves that file as /src/password.inc, which contains username and passwords in either clear text or hashes. And we'll write a plugin from the ground up that basically checks for that file, and if it does find that file, we will call a security hole. So before you write a plugin, what do you need to do? You need to actually, Nessus has a really great set of APIs to provide information to the user about your plugin. I will call these description functions, or the description APIs. Then you test for the flaw and you report it. That's basically it. Every plugin or every Nessus script you look at will probably begin with that if statement. The description variable will be set to true if it is run. If your Nessus script is called by the Nessus engine, before description will always set to true, so that if statement will always be successful. If I execute the same plugin from the command line, description will not be set, so it will probably return false or 0. In that case, the block of code you have in your if statement sets all the description values, so you really don't need that if you're not running your plugin in the Nessus engine. So always have the if description statement the first line of your plugin, and call your description API in that block. So as we write our plugin, this is what we'll do. Say if description, and in there you have the script ID function. Every Nessus plugin needs to have a unique ID. So I chose 99,999, because probably will not clash with any other existing plugin. You can use the script version function to set version information about your plugin. Script name to give your plugin a name, description, set a description, and require ports. Now what this tells Nessus is that when you start the Nessus scanning, it performs a port scan. So for example, if it finds a web server on port 80 and telnet on 23, it will call your plugin. But if it does not find a web server running, your plugin will never be called. And this is really good because it makes life much simpler and makes Nessus more efficient. You don't want your plugin to be executed when the engine knows that port 80 or there's no web server listening on the target host. And then you will need to call a script category function to set a category for your plugin. In this case, I chose at gather info because what we're really doing is gathering information about the remote web server. Here are a list of other categories that you can call: attack, denial, destructive, kill host, mixed attack. I kind of don't agree that. I think destructive attack and kill host, it's really difficult to understand what those are. I guess given the documentation that exists, you probably have to grep for these and look at how people are currently using it to get an idea of what those mean. And then you call the script family function. In this case, we will choose the family CGI abusers. If you go to the Nessus site, you can actually click on the plugins link, and it has all their plugins categorized by family. And the copyright function to set author information, so you get credit for your plugin. And once you have that put in a Nessus script and you put it in the plugins directory, if you connect to the Nessus engine using your client and you click on your plugin name, this is what you will get. So when I say Nessus provides you a framework, if you're actually writing your own scanning engine from scratch, as you can see, this provides a pretty good, framework already with, ways to categorize your plugins and all that cool stuff. The plugin itself, after the description, is pretty simple. We call the include function call. In this case, we include the http://func.inc include file, which basically has a definition for the isCGI install function that we're going to use later. But before that, we say get HTTP port default :80. Nessus is pretty smart. If you run a web server on port 8080, port will get that value. So, but by default, you want to pass it 80. So you're saying default value is 80. If you, as an engine, find something else, set port to that value. isCGI install is a Nessus function that is provided to you. Basically, you give it an item and the port number, and it will return true if that file exists on a web server. In this case, if it does, we call security hole, which will cause a report to look like this. All right? On the top right, you can see security hole, and the bottom portion, you can actually see the description we set, that /src/password.inc is usually installed by XYZ web application and contains username and password information in clear text, and we provide a solution. For more information about the Nessus language, if you go to this link, there's an extensive PDF. I think it's about 40 to 60 pages long, and it goes through every Nessus function there is. And it's pretty well done. The API library documentation, I think, is pretty well done. Okay, so let's move on to AdaCap. AdaCap, as of 0.7.0, recently revamped their entire code base. If you're using AdaCap from 0.6.x, the plugin API and all sorts of things completely changed. And I really, really like the new AdaCap. Right now, they have a GTK interface to it also. AdaCap, is a really powerful sniffer. It lets you also do password dissecting, so you can actually write your own dissector to sniff passwords on the fly. For example, the FTP dissector that AdaCap already comes with. There's the SMTP dissector. There's an MSN dissector. Everything you can possibly think of. What we will do is write a simple plugin that detects SYN packets going across the network. The inspiration for this really simple plugin was because if you download AdaCap, and as of right now, and you go into the plugins section, and you see a list of plugins that AdaCap comes with, there's a plugin called FindCon. When you enable it, what it basically does, it alerts you if there's a new connection being established on the network. And the way it does it is by looking at the network for ARP requests. Now, looking at ARP requests is a really, really bad way of identifying brand new connections, right? ARP requests are cached, and if you, for example, connect to yahoo.com from your internal network, you're going to opt for your gateway, not for yahoo.com. So what I did, I took that plugin and I modified it so we, instead of looking for ARP requests, we look for TCP packets. Once we get the TCP packet, we look inside it for the SYN flag, and if we find it, we alert the user. Now, I know this is a really simple plugin, but my goal is to fill the gap between the lack of documentation um, in Etacap, and I think I will probably email them and send them some documentation that they can include. Um, The great thing about a plugin also is that you can enable and disable it on the fly. So if you don't like something about Etacap, but you really don't want to change it forever, just write a plugin for it, right? So in our case, what we will do is every plugin has to define a struct plugin ops variable. In this case, we will call it find TCP con ops. And on the left, you will see the items, and on the right, the values that we set for each item. Etacap underscore version is required to be set to EC underscore version because the the Etacap engine uses it to, for example, if you compile a plugin and you later on use it for Etacap 0.8, which is completely revamped, probably look at the version information and give you a warning. Info, descriptive, name, version. The most important are the init and the fini. The init item is basically a pointer to our find underscore TCP underscore con underscore init function. That function will be called every time somebody enables the plugin, right? When you start up Etacap and you load a plugin, that is not enabling a plugin. You load it, it gets loaded, but when you click on it and you say enable, it gets enabled. That's when the init function gets called. When you click on it and say disable, that's when the fini function gets called. The function that does get called when you load a plugin, that is, you click on the plugin menu item and say I want to load a plugin, you point to the plugin. As soon as you point to that plugin, Nessus wants to load it, the plugin underscore load function will be called. So if you're writing an Etacap plugin, that is your main entry point. And so in this case, we call the plugin underscore register function, which passes it the pointer to find TCP con ops, which is the structure we just defined, right, at the startup. And what that basically does is sets the init and the fini pointers. Once that is done, and somebody actually clicks on the plugin and says, I want to enable this plugin, that's when the find TCP con init function gets called. In that function, we call hook add. And basically by passing hook underscore packet underscore TCP, what we're telling the Nessus engine, Etacap engine, is that every time the Etacap engine receives a TCP packet, we want it to call the parse underscore TCP function, right? Now if you look at EC underscore hook.h in the Etacap include directories, you will see other ways you can hook your function calls. For example, hook underscore packet underscore UDP or op request or op reply or ICMP. But in this case, we'll choose TCP. We return plugin underscore running to tell the Etacap engine that we have loaded or enabled successfully. And as you can probably guess, con underscore fini is called when somebody disables the plugin. In that case, we call hook underscore del to delete the hook. Parse underscore TCP is called every time Etacap receives a TCP packet. As you can see, if you go back to the find TCP underscore con init function, that's where we actually set parse TCP as the hook. So once you have the hook, the first thing we do is look at the flags. Now, the parse underscore TCP function is passed in a packet object, which basically contains the packet, the TCP packet that was captured. The first thing you want to do in this case is check to see if the TCP flags are set to the SYN flag, if the TCP packet has the SYN flag enabled. Now, if you want to check for more than one flag enabled at the same time, you can use the pipe, in C you can use the pipe option, pipe it, do an OR operation. So in this case, if you don't find the SYN flag, we return, we don't want to do anything with that packet. But if we do want to, if we do find the SYN flag set, then we go ahead and actually print, we call the user underscore message macro, which basically tells the user that, hey, I saw a SYN packet fly by, and therefore this host is trying to connect to this host on this port. And if you run that in the GTK client of Etacap, I don't know if you can see it, but the last line says find TCP/CON probable connection attempt from this IP address to this IP address on destination port 80, right? Justin?
Is everybody still awake out there? Now, the tools I'm going to talk about are a little bit different to Nessus and a little bit different to Ettercap because Ettercap and Nessus have a plugin architecture, whereas Hydra, who's familiar with Hydra? Everybody's used Hydra. It's a cool tool. Actually, strange that it does actually integrate with Nessus now. You can actually call Hydra from Nessus these days. But if you've actually ever had a look underneath the hood of Hydra, Hydra is actually not a plugin-based tool at all. What it is it's a tool which is designed in a very modular fashion. So while it's not trivial to like add a module to Hydra, it's relatively easy. So if, for example, the example that I'm going to give you guys here, basically it took about a couple of hours to write from like start to finish. So it's relatively easy to figure out what's going on. Now, it's written by Van Houser. I don't know whether he's here. Haven't seen him. thc.org is where you get it. As Nitesh mentioned, version 4.2 actually has this module that we're going to talk about, SMTP auth. It also has CVS and something else which completely escapes my mind in it as well. OpenGL, plugin to Nessus. It's a cool tool. Installing. Using Hydra is relatively easy. I'll just give you a brief introduction for people who haven't done it. Why it's so cool is because it supports so much stuff. It supports lots. I mean, basically, a lot of the things that you'll find commonly running on your networks. It also supports some rather unusual things, like for example, SAP. Being able to brute force usernames and passwords for SAP is kind of like cool, as well as a lot of your internet-based services as well. In general, you'll call it something similar to like this. There'll be a -L option, small cap or large cap for either a single user or a user list, small p or cap p for like an individual password that you're testing for, or for a password list, server, and protocol that you're actually going to be testing. Now, the real reason that Hydra is so cool is because it works in parallel. So rather than actually testing, password, it has a user configurable amount that it's actually going to do it. So by default, it'll test 16 username password combinations simultaneously. So I mean that has a little bit of an impact on how Hydra is actually designed, and it's gonna have a bit of an impact on like some of the stuff that we're going to have to like do with how our module is actually going to work. So how is Hydra structured? Well, it really boils down to everything that you have for your protocol that you're going to add all sits in this just one file, and they're called like Hydra dash and then the name of the protocol. So in this case, the one that we're going to do, it's actually called in the source tree Hydra dash SMTP auth. So there's Hydra dash SMB, SMBNT, telnet, etc., like that. Because it's modular, each one of these interfaces has the same same callback structure. They all get the same information which is passed from the actual Hydra engine themselves. Because you're going to have 16 instances, 40 instances, however many you actually specify of your module running simultaneously. And the stuff that we're going to do there, the pass through to it, it's all going to go to every single one of them. For those of you who don't know SMTP auth, this is going to give you the brief overview of what we're doing. Spammers worldwide are probably going to love me for writing this, but let's hope nobody does anything with that. We connect to port 25, SMTP. We use an ALO command because the authorization for SMTP is actually an extended SMTP command, so we're going to use ALO. Some servers will work with hello as well. They shouldn't, but they do. Then we're going to issue an auth login command, and what that's going to do is it's going to prompt us with a 334, I believe, response code, which says, I'm looking for authorization. Send the base 64 username. It's going to send us another response. We're going to send the base 64 password. So as you can see, this protocol is highly secure. So this is definitely why you want to be doing SMTP over SSL if you can. And I apologize for how terribly nasty and unfriendly my slides are, because I've chopped a whole lot of stuff in here, and really what I'm going to do is I'm going to go through the logic of how it works. So here's my module. First couple of things we're going to do is we're going to use hydra-mod.h, which is it defines all of the functions that we need. Hydra exit is something that we can compare against, which is really going to tell us that we've got to the end of usernames and passwords that we have to test. When I talked about the standard interface that every module has to actually support, it's by default called service underscore. Every module uses that. So we have service underscore SMTP auth. It has the engine passes in certain details for the benefit of your module. We have the IP address. We have SP, which is an internal socket. It's where you're going to get your usernames and passwords. You're going to read them from the engine. We have some options, which usually is really only used to say whether we're using SSL or not. We have a miscellaneous pointer, which when you call Hydra, certain modules require you to actually put an extra little bit of information on the end of them. Like I think only 3 or 4 of them use it. So if you require more information than what's actually passed in here, you need to get the user to somehow fit that into a command line parameter, and that'll end up in MISC pointer. And then we have FP, which is our external socket, which is where we're going to put our output to. So this is what's going to end up in the interface. And the port. Port may or may not be specified. If the user is specified that you want to brute force, HTTP on port 8080, this will be set. If this is not set, most modules, and you'll see it in this one, will actually use whatever the default port is. So the first thing we're going to do is we're actually going to register our internal socket. What that's going to do is it's going to really tell the Hydra module functions that we have. It's going to register this stuff so we can actually start pulling usernames and passwords in. So we actually can test those things. What we can do as well, and I'll talk about how the plugin's actually going to work, because it will make more sense if I do it this way. The way that we're going to actually do this is we're going to connect to the mail server, and then over that same existing connection, we are going to try and authenticate multiple times for efficiency. So we're not going to set up and tear down a connection every time. So what we're going to do is we're actually going to set up the connection, right when we call in here, and then we're going to actually, call a testing function over and over again for this way. So we have some nice functionality here. Connect TCP, you don't have to worry about doing your own socket calls and that kind of stuff. Supports SSL as well. Also has a connect UDP as well if you're having to be using UDP. So we're passing in the IP we're connecting to, passing in whatever port it is, maybe default, maybe whatever the user supplied, etc. Hydra report is basically fprintf. So it's just the nice way of putting an error out there. And Hydra child exit's really just the clean way to actually tidy up after yourself if something bad happens, and exit out of this particular child. Now remember that we're going to have multiple ones happening here, so we don't want to get too adventurous about killing things or anything like that. Actually, if anyone has any questions about what I'm doing, I'd appreciate if you left them in a couple of things here. Really what I'm doing is I'm just introducing to some of the functionality at the moment. Hydra data ready is basically a wrapper for select. It's going to see if there's anything there or not. Receive line is a function really for receiving input from our socket on a line-oriented mode. It's going to consume everything that it can. Make sure that you actually free these things afterwards, because it has a habit of using up memory. Hydra send, we can send data as well. What we're actually going to be sending here is remember we're actually setting up. So we've connected the socket, and what we're going to do now is we're going to send the ALO command. So we're going to say EHLO, and usually you'd have a host name or something or other. What this one actually does is it goes EHLO Hydra. It's hello, I'm Hydra. So we've got all that set up. What we're going to do actually, now we've actually got the connection set up, is we're actually going to start calling a function to actually start testing that. So here we have start underscore SMTP auth, and this is also following the convention that the rest of the tool, the rest of the modules within the Hydra actually have. And we're going to pass a lot of the details we have there. socket that we opened, IP port options, miscellaneous pointer, etc. So if something went wrong, disconnect, child exit. Actually, and here's where we actually go into the start SMTP auth. So actually, what I should mention here is we're going to have some logic which is actually going to like report back, but basically there's lots of different ways things can go wrong. So usually you should be actually going into this function after you actually have a nice valid connection. You figured out that your server actually supports what you're trying to do, and all that kind of stuff there. Here we're actually going to go into actually starting testing these things. We have the things that we pass through, have some things that are like defined in the way of printers. The Hydra get next password and Hydra get next login functions are going to get the next login password from the list of things we've got. Now, remember we've got like these multiple child functions running. So what Hydra is going to do is it's going to take, I have like 5,000 combinations of things to test. I'm going to split those things up, and each engine's going to get like 500 of them. So each child task is actually going to have a different list of things it's actually going to do. So that's going to get the next one out of that. Here we're handling the possibility that we might have empty logins and passwords. There is an option in Hydra, which is why I mention it. It's -E, I believe, for testing the instance where a user doesn't actually have a password. So it's always a popular one, especially on Windows. We're looking to see whether we have any data again. We're basically there, just throwing stuff away. Then we're going to send that auth login command. Auth login command is really going to start the process of like a process of actually authenticating. We're going to get some stuff back. We're comparing it to look for a 334. If you don't have a 334, something's wrong. We've got some error going on. We're going to use some of the nice functionality, base64. Hydra also comes with some MD4 and DIR stuff, which is mainly used for like SMB. It also has like the base64 thing there as well. So we're base64 in the username. We're going to send that out. We're expecting to get 334 in response. If we don't, something's gone wrong. Now, in this particular protocol, if it actually works, you get a 235. So in this case, my apologies. We have two different conditions that we can have. We either have it worked or it didn't. So in this case, it worked, 235. We're going to call like the Hydra report found host function. And what that's going to do is it's going to report back to the engine and say, I found a valid combination. Now, we're not going to run just to like the first one. It's going to continue running on. So hopefully the engine itself is actually just going to fill up with a whole lot of nice successful usernames and passwords for you. What we're doing in the middle there with the memory compare is, you remember that Hydra exit thing that we had? It's a string, because like remember our usernames and passwords are actually strings. For memory it's like FF00, FF00, FF00 or something like that. What we're doing there is, if that's going to be returned as our next login password combination, we got to the end of our allotted list of 500 username password combinations, and we can terminate. If we didn't get the 235, we're going to call and tell the engine that the pair that we did complete is completed, but we didn't find something. And equally, we're going to go like check and see if there's anything more. That's it for the module. Other than that, you need to add into the makefile. Hydra.c, you'll need to add some references into your module. Helpfully, there's a whole lot of comments saying add new services here. Makes it really easy to find it. And then you just need to add in default ports for your service into Hydra.h, and it's that easy. So here's an example of my patched 4.1 version. I think 4.1 still, as of like an hour or so that I looked, still the latest version. 4.2 is actually kind of been floating around since the start of the month. So I should expect that it would actually hit the THC site at some point, relatively soon. So here we have, this is the standard like run. I'm only trying one username, one password. If you wonder what that IP address is, I have no idea. I think it's like a Southwestern Bell like DSL account. It's random. Please don't go and attack it or anything like that, expecting there's actually going to be like a mail server on it. And there it is, like saying, SMTP auth returned that host, such and such. This particular combination is valid. Other useful functions, getNext peer is going to, we'll actually call this in the module, but I've cut it out of the slides. It's really what sets us up for having the username and password there. Connect UDP, we have that as well. The other thing is that we use Hydra receive line because SMTP auth is a line-oriented text protocol. It's real simple, real easy to support. If you're actually doing binary, you're probably going to have to use receive. Now we're going to take a complete change of direction. Now, when we're talking about like Nmap service detection, and I presume everybody has had like a good play with this, since like 3.48 that it was in there. I'm not going to go into any great depth on how to do this because there is a really good write-up by Fyodor on insecure.org about how this works in detail and all that kind of stuff. I'm really just going to talk about some of the things that's possible with it. It's all defined in a nice little text-based file, Nmap service probes. It's probably in user share, Nmap, wherever your services files and that kind of stuff are for Nmap. And that really defines the service like probing and matching like process for service identification. So what happens if we do have a service which isn't supported? Well, first of all, I'm just going to give you an example. That's what it is of something which is not supported. Well, first of all, it's going to say, service unknown, and then it's going to give us this massive signature. For those of you familiar with the OS signatures, it looks relatively similar with the the SF like stuff, details about your version of Nmap and that kind of stuff, and it has the nice little like URL where you can submit this to the guys and they can do things. They can write a signature for these things. Well, what do we do if we have a service which isn't supported? Well, if you have something which is reasonably, likely to be somewhere else in the world, really, the most sensible thing in that case would be, take that URL, submit it to the team. They can confirm it, give them an IP address if it's on the internet, and let the guys who really know what they're doing, write that stuff. That's option one. Option two is, you know what you're doing. You can always email them an actual probes and matches and that kind of stuff. That may be there, be helpful and stuff like that. But let's say we're running some funky stuff where it's kind of on the internet or our intranet. It runs over IP kind of. It's custom. You're not really going to find it anywhere else or anything like that. But I have a lot of clients who they're big 100,000 people things with custom applications running funky stuff on desktops, and you want to be able to find out where this thing is everywhere. In that case, you're probably going to have to write your own. Definitely probably write your own matches, maybe write your own probes. So we're going to talk about what these are at a high level. We have, it goes, the file basically goes, probes, ports, SSL ports, matches. What's a probe? Well, a probe is what Nmap's actually going to send to this port in order to elicit some response. The first one that it's going to send is what's called the null probe, which basically just opens the connection and just sits there for 5 seconds, just waiting for something to come back. That's a good example. Here's another one. They have the format like probe, protocol, probe name, probe string. This one's like a GET request. This one's out of the service probes file. It's a probe, runs on TCP. It's called GETREC. And then we have the queue and the delimiter. It's actually going to send the GET / HTTP, carriage and line feed, and it's going to send that off to this particular port. So that's going to be the probe that's defined. We're going to give it a list of ports that commonly you would expect this thing to run on. Now, this does not limit what Nmap is going to find. this is just going to be what it's going to look at first. Really, the way it works is, it's going to check through the things that it's like suspecting will be valid, first off, and then eventually things it doesn't know about it's going to try everything on. SSL ports, the same thing. Now, the really important part about this stuff is the matches, because the matches is where we're taking what comes back from the server. It can be binary, it can be text. In this case, we're going to use text because it's nice and easy. In that case, it's very similar to like the structure of the probe. We have match, the pattern, name, and then we have our M delimiter, and then we have our regular expression. Now, the regular expressions are all like libpcre, so Perl people out there, you'll love this stuff. It's all good stuff. We have the round parentheses with the Perl regular expressions where we can pull out the $1 there, for example. You can see where it's got like Microsoft IIS and it's got like the round parentheses. We'll pull those out. You can do $1, $2, that kind of stuff as well. It's really cool. The version info is actually not mandatory, but if you can actually derive that somehow from the connection, that's good to put in there as well. And I appear to have got to the end of the slides. Has anybody got any questions about either the stuff that I've been talking about or Nitesh?
One, do you think, this is a completely unrelated question to the techniques that you mentioned, but do you think the Nmap service pros thing is shamelessly ripped off from AMAP by DHC?
To an extent. I mean, from the point of view, I still use AMAP as well, personally. Actually, the question was, do you think that Nmap service version detection is a shameless rip-off of AMAP? It's also actually, from the point of view, very handy to actually have that in the same tool.
That is true. I mean, I use credit for the handiness part of things, but technologically speaking, there's nothing different.
Well, AMAP actually has, AMAP's been around for a long time. I mean, like way before there was public releases, it's been in development for since 99 or something or other, if I remember correctly from the change log. Yeah, so I mean, it's worth actually running both, but I like having my scans with at least the low-hanging fruit out of the way. So I can.
But that deviates away from, I guess, kind of be the devil's advocate.
Do you want to stand up here at the microphone? I'll turn on this thing.
I was kind of upset when Nmap did this, not because of stripping it off from AMAP, but it deviates away from the Unix way of doing things. That I want one tool that does port scanning, and I want it to just do port scanning.
True, but these days you want everything.
Right, exactly, that's the way it is. Yeah.
Anybody else have any questions? Ooh, that's very loud. I hope some of you are going to go out there and write some nice modules for Hydra and support. I got a special request in for HTTP NTLM. It's like I have a client who uses that extensively.
It's done. We wrote it.
Oh.
Yeah.
Just waiting for you to just complete.
Cool.
So it's done.
It's done.
Cool.
NTLM and NTLM over SSL.
Cool, thanks.